Going to go ahead and get started and say good morning and thank you for joining us for this year's UTRGV Virtual Earth Fest 2022. We're really excited to have you with us this morning and hopefully for the rest of the week. It is going to be a week-long, wonderful Earth Fest full of amazing sessions. We're going to see videos that talk about the different areas of our environment, the natural resources we're trying to protect on our planet. And here in the Rio Grande Valley, we're going to hear from students, we're going to hear from faculty, and we're also going to see a couple of videos that just in general talk about the wonderful natural resources that our environment, that our planet gives us. And so we are going to share with you this morning, and I hope I do this right. So I want to welcome all of you and thank all the faculty, staff, and students that are with us this morning from UTRGV, but also all those amazing teachers who are with us from our different, we have various school districts and high schools that are with us this morning who are streaming all this week's Earth Fest into their classrooms. So we're really excited about that. And we welcome you and thank you for joining us. We had quite a few of you last year and we're happy to hear that you were interested in joining us again this year. So thank you so much for that. As I mentioned before, we have some amazing sessions for you throughout the week, and we are concentrating these on the United Nations Sustainable Development Goals that are specific to the environment. So the United Nations Sustainable Development Goals are 17 that cover society, the protection of society, the protection of our environment, and the protection of our economy. And they're all interconnected, but within those, the environmental sustainable development goals, which are 5, are kind of distributed throughout this week. And we're going to start off with sustainable development goal number 6, which is specific to water. The natural resources that our planet gives us are very important to our health, but also very important to our economy, aside from the fact that it's important to preserve our ecosystems. Number one, because they are part of our survival. You know, they are part of what, again, we need from our planet in order to survive, in order to be healthy. But we also need these for our economy because these are natural resources that are used throughout life and throughout everything that we consume and that we produce. And so it's important that we understand how all these interconnect and how they work together. So this week of Earth Fest, we're going to touch on each and every one of those 5 sustainable development goals that are all about that protection. So as I mentioned to you earlier, it's just a quick hour and a half that we have, and we have several little videos that we want to share with you. So we're going to start off with again, these are the 17 goals for sustainable development. And we're going to start off with the very first goal today, which is sustainable development goal number 6. So we're going to cover several videos on water. And we're also going to hear from some of our faculty here at UTRGV who are doing a considerable amount of research, not just to review the problems that we are facing with reference to water, but the solutions on what we need to do in order to preserve that important natural resource. So I'm going to ask Jeremy, and by the way, my name is Marianela Franklin. I'm the Chief Sustainability Officer for UTRGV, and with us today is also Mr. Jeremy San Miguel, who is a program coordinator here at the Office for Sustainability. And this entire session, week-long session, is brought to you by the School of Earth, Environmental, and Marine Sciences, and also the Office for Sustainability. And we are in partnership with the Division of Finance and Planning, the Division of Research, Engage Scholarship, Community Engagement, Upward Bound, and Gear Up. These are all partners, and we're all working together to bring this to you. So thank you so much for joining us again this morning, and we're going to get started right away so that we can share with you all these wonderful resources that we have for you today. So first and foremost, we'll start with with this short video on Sustainable Development Goal number 6, which is to ensure the availability and sustainable management of water and sanitation for all. So thank you so much. And Jeremy, if you don't mind, please start sharing the video. Thank you.
Ensuring availability and sustainable management of water and sanitation for all. Open the tap and observe it for 3 seconds. Do you feel it? Its inexhaustible source can make us think it abounds, but it isn't true. Nowadays, more than 1/3 of the world's population suffers water scarcity. And if we add climate change, droughts and floods are what really abound on our planet. There are people that are constantly thirsty, that don't have access to clean water. Don't you think that now we should all be able to drink decent water? Is there anything more basic than that? We can do it. Cynthia Koenig is a reference that facilitated and improved the life of many people. Since 1 out of 6 transport 20 liters a day in a distance of 8 kilometers every day, Cynthia made use of her talent to design a system that helps them push water instead of loading it, which saves health and time. Her invention has achieved a wide popularity in Southeast Asia to Central America, stopping inequality that regulated women from occupying this task. You can also contribute from home in a million ways. 1. Never throw away oil in the sewage. 1 liter contaminates 1,000 liters of water. Take it to the recycling posts and organize a common collection with your neighbors and work colleagues. 2. Save water at home. Put on the dishwasher only when it's full. Close the tap when you soap up in the shower, and count 30 seconds so that water warms before getting in. You'll reduce consumption by half, and you'll improve your blood circulation without realizing. 3. At home, install flow reductions and tanks with double flow in your toilets. 4. Inform yourself of the volunteering activities to purify water in rural areas, or promote a project to finance water wells. 5. Encourage awareness initiatives in your family, community, work, and school. Share your achievements and good practices, and contribute to creating change in necessary habits. Where there is water, there is life. Is there anything more basic than this? Let's go for it.
Thank you, Jeremy, for sharing that. And for those of you who would like this resource, we are recording the session so that you have the opportunity to watch this again later, or we can send those resources out to you if you'd like. Just contact our office. These are some really great videos to share, and we have another one coming up called Water. What does water mean to you? This is a really important video that kind of gives us a perspective on the uses of water throughout. We tend to only think about the water that we use for drinking or for cleaning or for showering, but water is used for so many other things. So this kind of puts things into a little bit bigger perspective on the use of water. So Jeremy, if you can, please go ahead and share the next video. Thank you.
L'eau, pour moi,
我是马颖，来自中国。
المياه بالنسبة لي
El agua para mí,
Water to me is life.
Humans, animals, plants all depend on water.
Water to me, well, it's everything.
It's our food, our energy, and even the clothes that we wear.
Water to me is a scarce resource. We need to use new technologies for rational use and water conservation.
We need to recycle used water to reduce water scarcity.
Water is fundamental to grow and produce our food.
We need to produce more with less water.
Water to me is fun. I like to play and swim in the water.
Water to me means sustainability. It keeps life on our planet in balance.
We need to keep the water clean to have a healthy life.
Water to me is a human right.
In my region, people struggle to get water.
We need to distribute water evenly and make it accessible to everyone.
We need to preserve water for the life of our planet. We have to start now.
We will always, always need water.
So again, this is very short and brief, but it puts that perspective into all the different uses of water. We tend to forget that water is critical for our health. And so right now, many of the diseases that we face are diseases we face because we're drinking, eating, and breathing chemicals all day long. So it's really important to read labels and to understand what's in what we drink and what we eat and what we use on our bodies, because many of these issues and these diseases we have today come from all the chemicals that we're dumping into the water, into our soil, and into our air. And again, water is used for so many things that we need to really be more conscientious about the use of water so that we can preserve and conserve water. So next we have, again, another resource for you called Water, the Source of Life. In this video, you're going to hear from different faculty around the world that are working on research. After this, we will go into our own faculty and the type of research that they're conducting specific to water here in the Rio Grande Valley, so that you can understand what's happening to our water here locally and what we need to do to conserve it, because it is, like I said, a really big part of our health and our economy. I'm not sure if you all knew that before COVID, the Rio Grande Valley was making about $850 million a year in ecotourism. And a good part of that ecotourism is tied to water, because many of those tourists come to see the species in the water, and they're also using up a lot of our water while they're here. So it's important that we understand that water is important not just to our health, but it's important to our agriculture, to our food. It's important to all those species that live in the water as well. So it's important, it's critical that we start preserving and conserving our water. So we're going to go ahead and start this next video. Again, this one I think is a little longer, correct, Jeremy? It's, I think, about 12 minutes long, but it's very informative. It kind of helps you understand much of the research that's being conducted around the world with reference to water, because we are in a very tight spot right now in terms of water. We are losing a lot of the water that the planet has. So we're going to have to start getting creative about the way we use and consume water. So go ahead and share the video, Jeremy, if you don't mind. Thank you.
For food, water is for energy. We could not survive without water. So of course, this is a very important topic. So the Institute of Environmental Engineering at the ETH has a lot of research going on related to water, in hydrology and water resources management, in groundwater topics, as well as in urban water management topics. In addition, there is research going on about the origin of water, glaciology, and studies related to water quality in rivers and lakes, for example.
The project refers to the area of Jakarta, which is the capital city of Indonesia. And the problem there is that the main river flowing through the town has been increasingly under pressure due to enormous immigration. And the urban footprint increased more than 200 times in the last 40 years. The focus of the research is to try to demonstrate that it's possible to have a new paradigm in rehabilitating urban river corridors. The idea is that we combine different technologies based on different disciplines of environmental engineering and numerical modeling of water sciences, together with advanced surveying based on the generation of cloud point data sets and landscape architecture. And finally, also considering ecosystem surveys. So bringing together all these disciplines should provide a different view on how problems in urban river corridors can be mitigated, for instance, flooding and pollution, just to name a few of them.
My research is about glaciers. We want to observe or to investigate how the glaciers move in general. We observe the so-called ice quakes instead of earthquakes. And the ice quakes, they always happen every 10 seconds. And with that, we can get some information about how the glacier itself moves and what happens also below the glaciers. In general, we put the classical seismometers on the glacier connected with the receiver or a digitizer and some solar panels for energy. And with that, we just measure continuously what's going on. So every time, like for example, a crevasse opens, it cracks, and these cracks are visible on our seismometers. As we all know, the glaciers are shrinking in general. And we want to know if we have a rising temperature, warmer climate, how can it influence the sliding of the glacier, the shrinking of the glacier?
One theory is that it was already there from the beginning, but that can be challenged because it was very hot in that area. The other one is that comets delivered the water to Earth, and we are looking at meteorites. We do analyze these meteorites, for example, with a mass spectrometer. A mass spectrometer is an instrument where we can measure how many atoms of an element are present in a sample. So we do know then how much water is in a sample. And from that, we can make interpretations. Our results indicate that the water on Earth was there already in the building blocks of the Earth, and the comets only delivered a very small fraction. Just looking at the science question, we do satisfy a basic curiosity of mankind because we need water to explain life on Earth.
One of the big challenges is the increasing, growing world population. And we would like to feed that world population well, which means we need a better content in the food products that we have in terms of macro and micronutrients. On the other hand, we also try to produce more resource efficient, which means with less emissions, for example, in terms of nitrogen or methane. And on the other hand, we also have that dilemma between food as a normal diet versus lifestyle, which tackles then and addresses questions of ethics, for example, of animal welfare.
Rice fields, because they're flooded, the soils are under anaerobic conditions and they emit large amounts of the very potent greenhouse gas methane. In upland cropping systems like your wheat systems or maize systems, there's a lot of emissions of nitrous oxide, which are basically derived from the fertilizer that is being applied. There's actually only about 50% of the fertilizer that is applied that is taken up by the plant. And there are a lot of microbes in the soil that perform various transformations of that nitrogen. And one of those transformations leads to the emission of nitrous oxide. Currently, we are doing a greenhouse experiment where we're looking at the potential for crops with bigger rooting systems to be able to capture more of nitrogen in the soil so less gets lost. The losses of nitrous oxide itself are very small, but in terms of greenhouse gas, it's a very important loss because the global warming potential of nitrous oxide is about 300 times larger than that of CO2. So even though those losses are minimal, in terms of climate change, they have a very important role to play.
Zinc is an essential nutrient element. If we do not have sufficient zinc, our growth is retarded, our immune system is weakened, and we are more susceptible to infections with pathogens. Our trials are in Madhya Pradesh. This is a state in India which is in the center of India. The soils on which we are focusing are soils which have sufficient zinc. The problem is that this zinc is bound in the soil, so the plants have difficulties to take it up. What we want to do is to improve the conditions in the soil so that plants can take it up more easily. And this is done by improving the organic matter in the soil, because organic matter provides zinc to the plants. There are estimates by the World Health Organization that there are more than 1 billion, some people say 2 billion people in the world who suffer from marginal to more severe zinc deficiency. So it's a motivation, of course, that we like to do something where we have the potential that it helps mankind.
Meat consumption is always an ethical problem because people want to eat meat, and this means animals have to be killed. And in the case of chicken, the problem is male chicken cannot be used for production of eggs. So therefore, you don't have any use for them and they have to be killed.
We are trying to find in the existing genetics a breed which is able to produce meat and eggs at a satisfying level. We don't want to create a new breed. We want to check what is existing in the genetics.
The products will be more expensive. So therefore, it will be crucial how consumers will react to this price increase. Are they willing to pay a premium for more animal welfare? And I think that's an open question. And it's also an open question, how many consumers are being willing to pay for animal welfare?
The large challenges, they come due to the complex interactions that we have in this entire food system, which goes from production to processing to retail to the consumer, and how the consumer actually responds. And we produce and we act in that food system with changing environmental conditions, be it climate change, but we also have degrading soil resources. We have a scarcity of resources, be it nutrients, like what we need for fertilizers, or also for water with irrigation. On the other hand, I think as researchers, we also have the duty to work on relevant problems, relevant for society and relevant for the future. And these are the two main criteria why I'm doing what I'm doing.
So we want to thank you for watching this video as well. As you saw, it helps connect water to all of life, not just our food, but also our ecosystem and the critical need for water for production. Everything that we consume is made with water. So we hope that you enjoyed this video, but we now want to take you to the subject matter experts here at UTRGV that are working also in relationship to water. And for the students who are watching from our high schools, we hope that if you have a passion for the protection of water and its connection to life, that you have the opportunity to really listen to these faculty so that as you graduate and start looking at degree programs, you consider what it is that you have a passion for. And some of the leaders in sustainability here at the university that are working towards all 17 goals, but specifically today, you're going to hear from 3 of our faculty champions, sustainability champions that work very closely with water. So we're going to skip this video and show it to you a little later. We want to introduce you to Dr. Chu-Lin Cheng. He is an associate professor at the School of Earth, Environmental and Marine Sciences, and he has a joint appointment with the Department of Civil Engineering. I am sure you can understand why civil engineering and water come hand in hand. So he's going to give us a presentation on water, environment, and society. And as with everything else, you're going to see that we have him pre-recorded with a video presentation just for the smooth transition of our sessions this morning. I'm going to ask Jeremy. Jeremy, do you know if Dr. Chu-Lin Cheng is with us? Yes. So after the presentation, we're going to allow you to do some Q&A with him. And so we're going to ask you as you watch the presentation to consider your questions and either put them in the Q&A or the chat box. Or if you'd like to speak, we would ask you to please raise your hand so that Jeremy can unmute you so that you're allowed to speak. So Jeremy, if you want to, please go ahead and share Dr. Chu-Lin Cheng's presentation. Thank you. And good morning, Dr. Cheng. I'm glad that you're with us.
Hi, everyone. My name is Chilin Chang. I'm an associate professor with School of Earth, Environmental and Marine Science, and also Department of Civil Engineering. My expertise and research areas are in water resources, groundwater hydrology and remediation, which is pollutant removal. In today's Earth Day event, I'm going to share with you all some knowledge about water and, of course, its values to our environment and society. Us humans are part of the Earth system. We, along with the plants, animals, and even microbes on Earth, are part of the biosphere, and we interact with the other spheres constantly. We breathe air every second. We utilize water for many things, for electricity or even for recreation. And we also interact with the land surfaces at every second. We build bridges and roads and even urban buildings with soils and rocks from the lithosphere. We use a lot more resources from Earth system, the oil and gas that runs our cars or for energy productions, Even the diamond ring that you use to propose to your significant another, as well as lithium for batteries and microchips that made of rare earth mineral. Those are all the resources that we harvest from Earth. Among those, air and water makes our planet Earth very unique from others. That's why we send rovers to Mars trying to find water or life. And yet, water on Earth is one of the resources that's most undervalued and underappreciated. We almost take water for granted. Water is really invaluable. What's the true price for water? Water on the market now is so cheap, so we don't really treasure or we don't really value the water resources that we have on Earth. When we don't have electricity, life is very inconvenient because we are in the modern society. Everything runs on electricity. But what if we don't have any water? We won't be able to survive. Can you imagine one day or 1 week without a drop of water? Water means life. Without water, life is not possible. We might not be fighting for water yet, but we might be seeing that in the very near future. If there is a drought, who gets the priority to get the water? Is it for farming or for other economical businesses or for our households in the community? Speaking about fighting over water, with the increasing population and economical growth in our area, along with the intensified climate change, water demands are also increasing very quickly. Many countries and borders are experiencing tensions and conflicts over water. US-Mexico border is no exception. It's not only about water quality anymore, but about water quantity. We don't have enough for everyone, especially our areas are under water deficit, meaning we are not having enough precipitation over the water that we withdraw. While we are celebrating Earth Day this week, we are also celebrating World Water Day just last month. In the past 8 years, United Nations had various water themes in celebrating Water Day. Water related to many things, not only energy and food production, but also can be impacted by the increasing temperature and climate change, and also more and more extreme weathers. This year, the theme is groundwater, making the invisible visible. What's groundwater anyway? So groundwater is the water that's underneath our feet in the subsurface. Did you know that groundwater supports 41% of the US population? Did you know that in Texas, 99% of the drinking water for rural populations are from groundwater? Did you know that 80% of the groundwater withdrawal are used for agricultural irrigation? Because groundwater is under the ground, so it's not easy to be contaminated. But once it's polluted, it will be very difficult to treat. Groundwater might be out of sight, but it shouldn't be out of mind. So we have to test our water frequently and be mindful in terms of protecting our valuable water resources. So groundwater is really like a hidden reserve, like savings account underneath our feet. It's always there, it's reliable. This is the hydrological cycle on Earth. As most of you know, that water circulates in the environment in 3 forms. That could be liquid water or ice or snow, or it could be the vapor or moisture in the air. So when precipitation, like rainfalls or snows fall onto the ground, part of that becomes surface runoff in the river, in the creek, and a portion of those infiltrate and becomes the surface groundwater. Both surface water and groundwater will discharge into the ocean eventually, and through the land surface process, there are also evaporation and transpiration. So most of the water on Earth are in ocean, and they are too salty for us to use directly. The number one fresh water is stored in the ice cap or in the glacier. Groundwater is actually the second largest freshwater storage or freshwater supply on the planet Earth. The water that you see in the river, in the creeks, in the lakes, they are 60 times less than the groundwater. So you can see the importance of the groundwater in our planet. Groundwater is more abundant than surface water that we see. It's just the nature of the hydrological cycle. Here in the lower Rio Grande Valley, like El Paso, we just cannot get enough water supply from the surface water source, Rio Grande River. So the state helped us to build the brackish groundwater desalination plants. As you can see from this figure here, there are big capacity desalination plants, so we could meet our growing demand. So you can see that from not only Houston, but also here in the Lower Rio Grande Valley, the state has recommended to expand our facilities to use brackish groundwater. There are currently 7 desalination plants here in the valley, and the target is 23 facilities that could utilize brackish groundwater in the subsurface. So now you see the importance and the pretty critical role of groundwater in our environment and society. Unfortunately, based on our daily activities and our interactions with the land surfaces, Earth's land surfaces, we continuously to release some contaminants into the environment and also our water resources in waterway. So waste management is really important and critical. The best practice to protect our water resources is to prevent the water being contaminated. Everything that we put onto the ground and into the subsurface would eventually come back to us. If someone's littering upstream, the downstream residents will be utilizing that contaminated water somehow. So here I would like to share with you all a model that could demonstrate how the surface water and groundwater interact, and also the contaminants that could travel in the subsurface environment. As you can see here, the green dyes are introduced into the model, like the agriculture chemicals, pesticides, or fertilizers. When they are applied at the ground surface, they percolate vertically through the sediments or the soil. When the chemicals or contaminants reach the water table, as you can see here, the line here, water table, it starts to migrate along with the groundwater flow, and the contaminants along with the groundwater flow could interact with the local hydrological system, like surface water body, resakas, or Rio Grande River, or lakes even. So the contaminants along with the groundwater would discharge into the surface water body. They could further migrate down to the coastal area, like Laguna Madre or Gulf of Mexico. If eventually all the water and contaminants would go into Gulf of Mexico or Laguna Madre in the coastal area. So what this model really tells us is that surface water and groundwater are connected as one resource, and the contaminants, whatever chemicals that we put on the ground or store underneath the surface, they could essentially come back to us. They could contaminate the seagrass or the fish in the water bodies, like Laguna Madre. And if we were to use the water, contaminated water from the wells to irrigate crops or to feed our cattle or livestock, those will be contaminated as well. Here in the valley, we have two famous cases in terms of water resources contamination. One is Dana Reservoir, and the other one is McKellen Plume, which is gasoline floating on top of the groundwater. Both cases has been more than 20 years, but the treatment, the mitigation is still ongoing. Both have components in terms of surface water and groundwater. So as you might be aware, in the past few months, US, Western states, including Texas, has been experiencing exceptional droughts. This is the drought condition in Texas last year. And this is April this year, this month. So from this map, you could see that half of the country is under persistent drought condition. When we don't have enough water, how can we sustain our daily routines, our businesses, and our farms for food production? And yes, we do have too much water when hurricane season arrives. But don't think that we have too much water so we could just waste them randomly. This is because the increasing extreme weathers due to climate change. Now the weather patterns are very unevenly distributed in space and time. Can we do a better job in terms of conjunctively manage both groundwater and surface water? With the help of the better engineers approach, while we are developing our community, expanding our urban area, we could do a better job in terms of utilizing the available water if we have planned properly. And at the same time, we could do a better job in terms of mitigating the already contaminated water waste, water bodies. So we could be better off in terms of planning for the water for the next generations to come. It really takes all of us to build the water resiliency and sustainability for the Lower Rio Grande Valley. Protect our water, protect our environment, and remember that we only have one water. And eventually all the waste would come back to us. So do your part. Let's protect our planet Earth and environment together. If you are interested in learning more about water research, please don't hesitate to reach out to me. Happy Earth Day. And thank you.
Thank you so much, Dr. Chu-Lin Cheng, for this remarkable presentation, very informative. At this time, we'd like to let you provide a few comments and also wait and see if we have any questions from the audience. Thank you again, Dr. Chu-Lin Cheng. If you'd like to, Jeremy, unmute, make sure his mic is unmuted so that he can share a few comments. Thank you.
Thank you, Ms. Franklin, and and also Jeremy, in terms of the hosting this very amazing Earth Fest for this week. And I'm really honored to be the first speaker during the first day. So I'm a groundwater hydrologist, and also I do groundwater contaminations and conjunctive management for surface water and groundwater. And we have a lot of potentials in the valley. At the same time, if we could do a better job in terms of having this sustainable mindsets in terms of planning while we are developing our economy, will be better off for the future. And as you can see that we are experiencing drought due to the increasing climate change. yeah, not having enough water really might not be imaginable because we are kind of spoiled in US. But I will stop here and ready for any questions or comments that you might have.
I'm going to give you the very first question, and I hope it doesn't throw you off. But given that we have several high school students watching right now, we're being streamed over to several of the high schools throughout the valley. I'd like to ask you the question with reference to career paths, given that water is so critical and so important to us. What exciting news can you tell the students about, job market with reference to water? Because I know it's a very important subject matter, and I know that a lot of our students are very passionate about sustainability and jobs that actually protect our natural resources. So do you have anything you could share with them with reference to some of the degree programs we have here at the university?
Sure. So there are many job opportunities related to the water and also actually environmental protection for us. You could find job opportunities from state agency like TCEQ, Texas Commission for Environmental Quality, and even TWDB. You could see from the presentation there are data from Texas Water Development Board, TWDB. They are constantly looking for scientists and engineers that could help us better manage and better planning for water resources, both for surface water, groundwater, and even for the waters in the coastal area in Laguna Madre. And in terms of UTRGV programs, we have bachelor degrees in under Earth and Environmental Marine Sciences, but also Department of Civil Engineering. And both departments have a master's program also. And the pays are actually quite decent depending on your education level. The pay grades, if you have a bachelor, it will be ranging around like 40,000 a year. If you have a master, it could be ranging from 50 to 60,000 a year. Yeah, I think I will stop here.
Oh, no, thank you so much for that. We actually, I do want to share with the audience that both TCEQ and TWPD, they also do internships. They take internships during the summers. And I know because we've had students from our office that work in our office who leave us in the summer to do internships with them. So yes, you mentioned two of the strongest departments here in the Rio Grande Valley that actually always have job opportunities and internship opportunities for students. Jeremy, I want to go back to you to ask if there are any questions in the chat or in the Q&A for Dr. Cheng. If not, so we can move to our next presenter.
No questions as of yet, just a few comments of commemoration on such a great presentation. Thank you, Dr. Cheng.
Wonderful. Thank you so much, Dr. Cheng. We really appreciate you participating again this year. We really appreciate all the amazing work that you're doing, both here at UTRGV and for the whole region. Your research is very, very valuable, and we appreciate everything you're doing. Thank you so much.
Thank you all.
Thank you. So next we have with us Dr. Hudson Deyoe. He too is a professor at the School of Earth, Environmental and Marine Sciences. And his focus this year is on seagrasses as a barometer of water quality. So I'm going to ask Jeremy, is Dr. Deyoe with us so that we can do a Q&A afterwards, or is he busy this morning?
I believe he is busy, otherwise engaged.
Okay, so we are going to go ahead and provide you his video pre-recorded presentation, and from there we'll move on to our next presenter after him. So again, these are sustainability faculty champions who are working towards these sustainable development goals, and in particular today in water. And so we have Dr. Hudson Deyoe. We also have a podcast with Dr. Hudson Deyoe. So we'll invite you, we'll share the link with you later. As we wrap up, we'll share several resources and you'll have the ability to also listen to him and on a different subject matter still related to water on our Sustainability Adelante podcast series. So Jeremy, if you could please share his video, thank you.
At least I am, okay. Seagrasses, as you can see in the picture there, okay. Happen to be some fish there too, okay. And seagrasses is a barometer of water quality, right? I've been at the university for a while. I can tell by my gray hair. And then I spent a lot of time on the coast looking at seagrass and trying to figure out what they're doing. So first is, what are seagrasses? Here's some pictures that obviously not underwater, okay? There's a thing called turtle grass, and you can see the leaves, the roots and stuff like that. They are actually normal flowering plants. These happen to be flowers right here. They're not much to look at, okay? We got 5 fairly common species, the 3 most common being turtle grass, which you can see there, okay? Shoal grass, which I don't have a picture of, and manatee grass, which is this one over here, okay? The structure is all pretty much the same. It varies a little bit from species to species, but the shoots or leaves, okay? The probably the part that does the photosynthesis for the plant, okay? And then the rhizome is technically in horizontal stem, okay? And these are shoots that come out of that stem, that rhizome. So it's kind of like a plant. Instead of going this way, it goes this way. But also the roots come out of the rhizome too. Also, obviously doing what they always do, anchor and absorb nutrients. Okay. In the lower Laguna Madre, about half the bottom is covered with seagrass. It's a major player in the lower Laguna Madre. Why do you want to keep them? Okay. Here's a little better picture here. You can see the fish. They have to be pinfish. Okay. This is their habitat. This is where they live, okay? Pinfish are just one species, there are tons of other ones, shrimp, crabs, okay? Little shrimp, some don't get so big, and various kinds of crabs, okay? So it is a place to, if you're little, to hide and, you know, be able to do what you need to do without getting eaten, okay? And then obviously predators do come, okay? And so it's not like you're going to be in the seagrass, you're safe forever. Okay. The other picture here, these bubbles, that is oxygen produced by the seagrass. See the leaves there. Okay, they produce tons of oxygen. Okay, on rare days, calm days in summer in South Texas, the water literally fizzes with the amount of oxygen being produced. That's not very common. Okay, some of the things they do for us. Okay, they stabilize sediment. Okay, they keep the water nice and clean so it doesn't get all muddy. Right. And they improve the water quality. They absorb nutrients. Oddly enough, unlike land plants, seagrasses can absorb nutrients through their leaves as well as the roots. Okay? But they improve the water quality by keeping the turbid water out and absorbing those nutrients. Unfortunately, our seagrass is not doing so good. Okay, lots of numbers here. We'll take a look at just parts of it. Okay, so we have different data from different years: 1998, 2005, and 2009. Okay, and here acres or percent cover. Let's just look at percent cover. Okay, and so they have dense grass, sparse grass, and bare grass for bare areas. Okay, they combine those here, 88% and 11%. Go to the end here and combine these two dense and sparse together. Now we got 55% and 42%. Okay. Then you can see the trend here. The bare area is increasing over time. Okay. And you're losing a lot of the dense and the sparse. Okay. Happens to be an decrease in dense and increase in sparse from 2005 to 2009. Just that 4-year period alone. So why is this happening? Okay. Well, here's a little more detail, more colorful way to look at seagrass. And here's 1998 and 2012. Okay, bare in both of them is red. Okay, and so you can see a little bit here, a little bit there. But in 2012, there's massive areas in which there's bare. Okay, Halagoo is the grass I didn't show you before. They unfortunately we've changed the colors. Halodulius is turquoise, whatever here, lots of it here, and here the halodulia is this yellowish thing. There's still a lot of it. Okay. The big differences are these things like Thalassia, which is this here, that brown area, orange, and the blue area down here. Okay. So significant loss in those. So there's less seagrass, and the amount of the different species, the three major species, has changed dramatically also. Okay. So there are several possible reasons for the cause of decline. Okay. Again, a lot of numbers here. Let's look at chlorophyll right now. Chlorophyll, this is the amount of chlorophyll in the water due to phytoplankton, little tiny algal cells in the water. Okay. The more chlorophyll, the more phytoplankton in the water, meaning there's more stuff to get in the way for light to get to the bottom of the seagrass lip. Okay. And so we have different areas here. Okay. Rio Colorado, Green Island, Bay West, BC, and South Bay. I can go back, and Rio Colorado is right here. Okay. This is a major ditch for the valley where a lot of treated effluent and stuff comes in. Okay. The other areas are not as close, and so presumably you hear a lot of nutrients coming in, so you might expect to see a lot of things growing there, like phytoplankton. And so we do see here the chlorophyll levels for the Rio Colorado is around 22. Okay, Green Island and Bay West, ABC, these are all further south. Okay, and clearly a lot lower than what they are for the Rio Colorado. Why there's so much chlorophyll is because there's nutrients there. Okay, and so we'll look at things like nitrate. Okay, so here is the average value for nitrate. Okay, this is a plant nutrient. Okay, also used by algae, 0.87. And for the other ones, all way less than that. Okay, also for phosphorus. Okay, also a plant nutrient, 0.16 for the Rio Colorado, and way lower for the other. And one last one, it's a little quirky though, is ammonia, 0.17. Okay, it's pretty high here in Bay West, but not much of a difference in ammonia, but for nitrate and phosphorus, clearly the Rio Colorado is putting in a lot more nutrients, meaning more chlorophyll, meaning less light for the seagrass. So these nutrient sources, here's the watershed for the Rio Colorado. Okay, there's that's Harlingen, I guess there. Okay, and Brownsville over there, you can't see quite that. Okay, but it's a major place for drainage water to come from the valley into the lower Laguna Madre right here. Okay, this fellow here, he was helping me. We were actually collecting samples in one of the tributaries that goes in the lower Laguna Madre, doing things like measuring nitrate and phosphorus. Okay, and here's one of the other students used for me. Here's at one of the drains coming in, and we were sampling that also. So with those, lots of nutrients to get things to grow. Okay, this isn't here, but this is called the Texas brown tide. That's what I came to Texas to study. Was this? Is a little phytoplankton thing that lives in the water. It colors the water brown. It's called the brown tide, but lots of it. You can see the white rod there virtually disappears because there's so much of it in that water. All right. This is another student that worked for me. She's now a Texas Parks and Wildlife game warden, but she was doing a research project, and I don't know why she's smiling. She was trying to find the seagrass. There's our pole here. We went back to monitor seagrass, and you can see all this stuff here. This is seaweed. Okay, this is the Rio Colorado is right over there. You can't see it. Okay, and there's a lot of seaweed because there's all these nutrients coming in, and not surprisingly, despite her efforts to find the seagrass, there virtually wasn't anything there because there just wasn't any light for them. Okay, with the stuff growing on top of the sediment, the things get kind of ugly underneath. Okay, where there's no light, things become anoxic, meaning no oxygen, and that ends up producing the stuff called hydrogen sulfide, which is also called rotten egg gas, which happens to be toxic to animals and plants. So here's a little more detail on that. This is a little sketch of a seagrass here, the rhizome and the roots. Okay, and this on a normal day with lots of light, okay? So the plant is producing oxygen. It's got the little routes to push that oxygen down to the rhizomes and the root. And it actually leaks some of that out around the rhizomes and root, creating a oxygenated safe zone, okay? Meaning that if there's oxygen there, oxygen and hydrogen inactivates hydrogen sulfide. So it's a safe zone for the roots, okay? If you reduce the amount of light, you get something like this, okay? This happens at night every night, okay? But the plants have got a bit of a reservoir of oxygen. But if you extend that for days and days, you begin to get something like this, okay? So maybe not so much oxygen coming down, and then your little oxygenated zone is reduced, okay? And now your roots begin to be affected, and maybe eventually your rhizome too, okay? And that's where the nasty hydrogen sulfide comes in. So less light means less light for photosynthesis, also means less light to produce oxygen that will keep the roots and rhizomes healthy. The other one, a big one, is salinity change, okay? Look over here, this graph. Here's the water types of their salinities, okay? Normal ocean water has what's called 35 parts per thousand of salinity, okay? And so freshwater clarity is 0, and you can get up to 70, even higher than that. And these are the different species. Here's the 3 major ones: shoal grass, manatee grass, and turtle grass. And you can see each one has its own kind of preference, okay? Shoal grass can handle a bit more salty, manatee grass not so much, and the turtle grass kind of in between. This one I didn't show you is widgeon grass. It actually can handle much more, less salt, so it's like fresher type of thing. So the issue is, if the salinity in the bay is going too high or too low a lot, then that's going to adversely affect the seagrasses by particular species, okay? Ones that are more fussy, like the manatee grass, might be the first one to be affected by when the salinity goes too high or too low, right? So when you have tropical storms, that of course water comes into the bay from the land, okay? And so if you get a lot of fresh water coming in, the salinity goes down for a long period of time, and then that's not a good thing for the seagrass. Kind of the death knell for the seagrass, if that salinity, say the reduction of salinity, okay, gets down to the roots and rhizomes down in here, that will eventually kind of kill the seagrass entirely. If it's kind of a light duty short term, it only affects the root, the shoots, okay? Longer term can affect the roots to rise. The other one is us. Well, actually, all of this is related to us. You can see the picture here on the left, okay? Those are prop scars. I also call it plowing, right? And you can see here's a motor, and it's nice and clean. There's no paint on the bottom because it's been doing this type of thing, okay? These prop scars, they stay there can stay there for a long time, okay? Years, perhaps, okay? You can see there's lots of them here, okay? I don't know how old they are, but some of them are relatively fresh, and some of them might have been there for, 5, 6, 10 years, okay? The problem with when you do this, why the boats are here is because of the fish. If you just ruin the habitat for the fish, well, your fishing might not be quite as good as it used to be. So what seagrass need is enough light, salinity, not too high, not too low. They need some nutrients, but not too much, okay? And proper sediment. Here's a picture of some sediment from the bay. It's kind of a dark color. That's due to that hydrogen sulfide. The plant does have a way to deal with that. We already talked about, but it doesn't like, rock, can't deal with rock, but sand and mud and stuff like that, it can deal with that. So it's not like you can just put seagrass wherever, okay? You have to have the right set of conditions so in order for them to grow. So how do you keep them? Reduce the nutrient loading to coastal waters, okay? Particularly the lower Laguna Madre. TCEQ, which is controlled or is a regulatory agency in the state that controls water quality in the state. There's no particular criteria to protect seagrass, okay? There are to protect other uses, okay? But none protect seagrass. The Rio Colorado, which was a major nutrient source, has a watershed protection plan, okay? And BMPs are best management practices, And what this are recommendations to farmers to how to reduce the amount of nutrients coming into the Arroyo Colorado. Okay, that is entirely voluntary, but they are a good thing, and people seem to be picking up on that. Regulations, state regulations. Texas has a law to prohibit uprooting of seagrass with a boat. Okay, so you can get a Class C misdemeanor and a fine of $500. Okay, the simple thing is, who is going to be there to give you the ticket? Okay. The game warden, well, they have lots of things to do, and they can't sit there waiting for the person to start up his boat and to chew up some seagrass. So despite the law, there hasn't been a heck of a lot of impact of this regulation. Probably the most feasible way to do this is to educate the voters and the public about seagrass, why they're important, why you want to keep them. If you're a fisherman, you should love seagrass and do everything you can to keep them there. Okay. The Texas Parks and Wildlife does have, you've seen occasionally billboards and signs and ads on TV occasionally, okay, to try to educate folk. I'm trying to start a thing called the Seagrass Stewards of Texas, which is clearly a grassroots organization to educate and, try to take care of the seagrass of Texas. Okay. I think that's about it. And obviously, we don't have time for questions, but thank you, and appreciate it. Have a good day.
So I want to thank Dr. Hudson Deyoe for his presentation. As I mentioned to you, he's not with us this morning, so we won't be doing Q&A. If you would like a copy of his presentation, we do have a recording of today's session, or if you can contact myself or Jeremy, we would be happy to share this presentation with you as well. So next we have a very dear friend and faculty member, Dr. Jude Benavidez, who's been a sustainability champion from the very beginning and has been participating in our Earth Fest now for several years in a row. We want to thank Dr. Benavidez for joining us this morning. He is with us. And so next we're going to hear his presentation on hydrography of the Rio Grande River Delta. He has been doing and conducting research in this area for many years now. And again, one of our top hydrologists and sustainability champions and subject matter experts when it comes to water here in the Rio Grande Valley. So thank you, Dr. Benavidez. We will open up the mics so that he can answer any questions you might have. And just so you know, Dr. Benavidez, I'm going to ask you the same question I asked Dr. Chu-Lin Cheng about the opportunities. One of the things, opportunities for jobs and what the market looks like, because one of the things I heard Dr. Hudson Deyoe say, which I thought was a little funny, was he found it surprising that the young woman in the photograph that he had was smiling. And I have to share with the students from the high schools that are with us today is that jobs in the environmental services are so much fun for those individuals who really are passionate about protecting our environment. And I say this because at one point, my daughter came home crying from high school, saying she didn't know what in the world she wanted to be, and all her friends already knew what they were going to study in college. And I asked her, well, what do you not want? And she says, I don't ever want to be stuck behind a desk. So she chose a degree path in environmental sciences, and she is very, very happy. If you are one of those individuals who are very connected to nature and really want to have fun doing your job, I hope that you entertain some of these amazing degree programs we have here under the School of Earth, Environment, and Marine Sciences, civil engineering. I mean, there's so many out there that are connected to our environment and protecting our environment. So I hope that you will pay attention to Dr. Benavidez, who has a remarkable presentation for you as well. And Jeremy, I'm going to ask you to please share his presentation, and then we'll open up for mics for Q&A right after. Thank you.
Good afternoon. My name is Dr. Jude Benavidez. I'm a professor of hydrology and environmental sciences at the University of Texas, Rio Grande Valley. I'm here today to talk about the hydrography of the Rio Grande Delta and the region's resacas. Here, you see here some pictures describing the Resaca area up here and some photos, some pictographs or artist renditions of some of the varied species, fish, birds, flora, and fauna that we have in the Resacas, and a beautiful panoramic picture of one of the Resacas in Brownsville, Texas. Starting off by a simple definition, what are Resacas? Resacas are isolated and abandoned distributaries or secondary channels or abandoned riverbeds of the Rio Grande River, where the natural flow has been cut off naturally. And they're not only oxbows. Some of them are oxbows, they're very small, and some are very long secondary river channels or ancient riverbeds where the river actually used to flow. Right now, the water levels in these Resacas are low. Our water levels are maintained through pumping action or water augmentation, being pumped from the river because they're isolated from the river naturally. And that water that you see in Resacas is either local rainfall, but most of it is probably because water is pumped into them. So we'll get into that here in a little bit. Let's talk about the area. The Rio Grande River Delta is located in the downstream end of the Rio Grande River watershed. This is a very large watershed, okay? One of the largest in the United States and in Mexico, with the headwaters of the Rio Grande in Colorado, flowing through the upper Rio Grande through New Mexico, and the upper Rio Grande ends, hydrographically speaking, about right here, about Fort Quitman. Down here is the lower Rio Grande, with the vast majority of the watershed now in Mexico, and the various rivers in Mexico, like the Conchos, the Salado, the Pesqueria, the San Juan, and others, provide a lot of the water flow into the river that flow past or through the lower Rio Grande Valley's portion of the lower Rio Grande River. This is an image from a publication that one of our grad students and myself and Dr. Heiss and Dr. Reisinger and Dr. Grove, Samantha Moore was her name, and she published this paper. We published this paper in the Journal of Coastal Research. It just published a couple months ago, January 2021, called Evaluating the Impacts of Dam Construction and Longshore Transport Upon Modern Sedimentation with the Rio Grande Delta in Texas. And I show this to show that this is the study area we're going to be talking about right here today. It is the river is an international border between Texas and Mexico. And you can see here that the Rio Grande catchment or river basin is amongst the largest in its area. There are much smaller rivers in the Texas area, the Guadalupe, the Colorado, the Brazos, the Trinity, the Sabine, the Nueces, and even smaller rivers in Mexico over here, like the Rio Soto La Marina and the Rio Panuca and some others in this area. So you can see that this is a very large basin that provides a lot of water and sediment flow into this portion of the river. Unfortunately, for the Rio Grande, it is not so grande. Number one, it is not a large flowing river like the Mississippi with a base flow or regular flow of millions of gallons, in over a brief period of time. It's a very slow flowing river normally, sometimes in the hundreds of cubic feet per second instead of the hundreds of thousands that the Mississippi River will flow. But it can rage suddenly with high rainfall events, usually brought in by hurricanes or by frontal systems. And when those hurricanes hit periodically, that rain would fall in northeastern Mexico and rage through the river, and the river would suddenly flow, suddenly wake up. And that's why they call it the Rio Bravo in Mexico, or the Rio Grande later on. Okay? But now we've dammed that river up. You can see these black lines here represent dams. And those dams right there, those little black lines here, Falcon and Presas Garcia, or Gomez, excuse me, along with Amistad and other dams, prevent those large flow systems. So the delta, which is not only here, but even historically can reach out into the Gulf of Mexico over a period of larger geologic time, is an area of interest for researchers. This is a geologic map of the region showing in this color green right here, the lower delta wetlands from the Holocene period, okay, and this is a relatively modern delta as compared to the older portion of the delta shown in this color green, right? And this color green here was adapted. This is also from our publication, 2021, but this area here was adapted by another publication from Dr. Juan Gonzalez, who also is a geologist here at UTRGV, who some of you may know and have taken classes with. So if you had to identify the delta region, it's largely the green area right here, not up here, but the green area right in this region, with the more modern delta being here in this region. Now, the watershed in the US side, okay, to show the US, the area of water that drains to different features in the lower Rio Grande area can be defined by 3 different watersheds. The Resaca Lower Laguna Madre watershed right in here, the Arroyo Colorado watershed, and then there's the floodways and the Hidalgo drain watershed that's not shown in detail right up here. Watershed is an area of land that drains to a draining feature or point. Okay, and if you're in this purple area, the Arroyo Colorado, all right, drains rainfall that falls in this area and it reaches this outlet right here, the lower Laguna Madre. If rain falls in this green area, it will either collect in a Resaca and potentially reach the ship channel or drain through some smaller drains into the Brownsville ship channel and eventually lower Laguna Madre. That is different than if it were to fall right along the river or come from upstream and flow through the river and reach directly into the Gulf of Mexico. That's a big important point for folks to know hydrographically speaking. The drainage patterns of the valley, if rain falls in this area, this rainwater, unless you live right on the river, and I'm talking a mile or less from the river, your stormwater or water that falls on your yard or the streets that you drive on or the houses that you live in or the places you work on do not drain to the Rio Grande. They drain to the Arroyo, to Resacas, or drainage ditches that flow into the lower Laguna Madre. Now, showing this area, this is an aerial photo with the Rio Grande River shown in dark blue. And these lines here represent indications of the ancient abandoned or partially abandoned distributary system or secondary channels or ancient flow channels of the Rio Grande, with these being very old. Okay, again, this is the area, if you look at the geologic map earlier, very old, and these being more modern. Some, just because they're shown in blue, do not misunderstand, these are not flowing rivers, okay? These are abandoned, meaning that the river no longer flows through those channels directly. And if there is water present in them, it's either because it's just recently rained or we pump water into them, typically for the purpose of irrigation conveyance, moving water from the river towards agricultural areas that need that water. Or we collect stormwater, floodwaters in them, or we pump water into them for aesthetic purposes and for maintenance and maintaining of habitat. Okay. Now, showing this area here, this is a LiDAR image showing the topography of the region. I want to show a close-up of this for you. This is the U.S. side. This is Brownsville right here and Harlingen right up here. Okay, and this is the South Padre Island. And you can see these blue lines represent the Resaca systems. Okay, and you can see that alongside this blue line, there's some yellow. Okay, and that yellow is about 10 to 12 meters high. Compare that to either side of this Resaca, which is Resaca de los Cuates right here, is orange or brown, and that's lower, which is surprising to people, that Resacas are actually higher than the land around it. This is because the Resacas are sedimentary depositional features. When the river would flood its banks, it would bring water and sediment, flood out of its banks and deposit the sediment nearby and create natural levees, not human-made levees, like the levee we have right here along the Rio Grande, along with the border fence. We have natural levees that create a higher area. And you can see those higher areas here, 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 and to a lesser degree here, because this is an older system that has been washed away. You can even see remnant ancient distributaries of the Resaca de los Cuates right in here. If you follow the mouse, you can see these little lines flowing away. Those are ancient Resaca systems of ancient Resaca systems. Okay? And so this means that the water will flow down the river and then flow outwards. Distributary means the opposite of a tributary. So water is flowing outwards away from the river in this direction through these channels. This is the same lines over a USGS map, so you can see where they are through San Benito, through Los Fresnos, a lot through Brownsville, and the 5 major Resaca systems we have here. Pink from north to south, the pink one here, Resaca de los Fresnos. The purple one, Resaca de los Cuates, which actually flows through Los Fresnos. You would think Los Fresnos flows through there. Actually, Los Fresnos flows through San Benito. The largest system we have here, Resaca del Rancho Viejo, which flows through Rancho and Brownsville. Resaca de la Guerra or Palma, which also flows through Brownsville, and the small but very important town Resaca, deep in inner city Brownsville, downtown Brownsville, which drains most of downtown Brownsville. Here in blue, flashing in blue, are the Resaca systems with their associated oxbows. These little bows or bends that form around these, or that are formed by the river, and then it decides to go straight through geologic processes or through erosion and depositional processes. Those are what we call smaller oxbows that are much smaller than these secondary channels and distributary channels of the Rio Grande. Now, we've discussed a little bit in very short time of the natural hydrographic features, the Arroyo Colorado, some of the drainage ditches, the large drainage ditches, and of course the Resaca systems in both the US and in Mexico. However, there is a very dense network. This is just showing a portion of it, of irrigation canals and drainage ditches that are interspersed throughout all of these water features. So the combination shown here with these light blue and light green lines, the light blue in US, the light green in Mexico, the combination of all of these features form and affect the hydrography of the Rio Grande River Delta. One second, just about done. Sorry about that. Now, the one last slide here, because I know I'm at about 11 minutes here. Resacas in general, just because they are no longer connected to the river and are no longer necessarily flowing with river water on a regular basis, doesn't mean they're not important. Resacas play vital and multiple roles and are understudied in terms of the relative importance of these roles. Number one, they provide flood protection. They are, even though they are higher in the area around it, they have the capacity to carry a lot of water because they used to carry the river's flow. And so they can provide stormwater detention and thereby flood protection. Raw water storage. Yes, we use resacas for raw water storage. We treat that water and we may use it for drinking. That may surprise some people, but we do the same thing with the river water, and it's the exact same water. Irrigation conveyance means we use it to transport water from the river to agricultural fields that are 10, 15, sometimes 20 miles away. We use them as irrigation canals or conveyance features. Habitat for bird and wildlife species, improved aesthetics, looks and feel, microclimate effects. They actually have cooling effects for the areas right around them. Park areas, opportunities for recreation and ecotourism, even economic development potential for vast areas in and around Cameron County. But most importantly, resacas represent a scarce commodity in South Texas, a feature potentially of surface freshwater bodies that are used by humans, that are used by flora and fauna, and that are used by the environment locally for a vast array of purposes. I hope you've learned a little bit about the hydrography of the Rio Grande River Delta, and in particular the resacas that are so near and dear to my heart and provide the region of deep South Texas and northeastern Mexico with a sense of place and a unique feature that is not found in many places around the world. Thank you, and I hope you have a great rest of the week.
Thank you so much, Dr. Benavidez. That was an incredible presentation. And I do have the first question for you because it was brought up here in our office not too long ago. One of our students asked the question, what is the difference between an irrigation ditch, a drainage ditch, and a resaca to the naked eye? I mean, an expert like yourself, you know exactly which one is which, but for individuals who are just driving by and don't know the difference, is there something that you can share with us to the naked eye that says this is irrigation, this is drainage, and this is a resaca? There's a difference between the three.
Sure. Can you hear me okay?
Yes, we can hear you perfect.
Excellent, great. Yeah, that's a great question. It doesn't necessarily mean that experts know exactly. I mean, because all the water's green, right?
Right.
Here's a couple key details. Number one, an irrigation ditch is going to be usually elevated because it's going to be water that's pumped and you need it to drain down, right? So you usually are like on a road and you're going to see something up a little bit, maybe even just a few feet. And you'll sometimes see a concrete pipe, a vertical standpipe, they call it, sticking up in the air by it. So if you're standing up really high, you walk up to it and it's really straight, that's usually an irrigation canal. If it's low and it's straight, okay, at least a part of it, and it's relatively narrow, we're talking about 20, 30, 40 feet, that's usually a drainage ditch. And you're going to see that drain ditch go probably to the next road and maybe possibly under a small bridge or usually through some pipes. Sometimes don't see those pipes because those pipes are underwater. That's going to be a drain ditch with usually steep banks, and you don't want a lot of trees around that drainage ditch because you want the water to flow quickly. Sometimes they do get grasses and brush and stuff that gets built up, but that's supposed to be cut down routinely because for the purpose of the drain ditch is to move that water fast. A resaca is typically not going to be straight. It's going to be much wider, and it's usually going to have a lot more trees alongside the banks and a lot more flora and fauna present in that system. So if you see a wide water body, it's not straight, doesn't have steep banks, and it's a lot of trees around it, that's typically a resaca. There are exceptions to these because you can come up to a lake or you can come up to an irrigation or a drainage detention pond that may look very similar, but by and large, that's kind of a key quick guide to determining the differences between the three. And that's an excellent question.
Thank you. We had that question here in the office, and I tried my best to explain, but without the visuals and the picture of it, I don't think I did a very good job. I just made reference to the natural versus the man-made and how you can see the difference between the two.
Yeah, a key thing in nature is anything that's usually that's like really straight. If it's really straight, it's usually human-made. Yeah.
Right, right. So thank you for that. And also the question I asked Dr. Cheng, with reference to job placements and job market and career paths, what is your experience? You've had so many students come through your program, and I know they're all also doing fantastic and have these amazing jobs. I just want to share with our high school students that are watching today, in case they have, interest in these fields, what they can expect, what they can experience.
Yeah, sure. I'm going to add a little bit because I did hear Dr. Cheng's discussion and adding on to some of the job opportunities that are present with TCEQ, with the Water Development Board, through consulting, through the private sector, and actually through education. If you want to be a hydrologist, or if you're thinking about working with water, you don't go get necessarily a degree in hydrology. What you're going to do is you're going to need analytical skills, you're going to need communication skills, you're going to need critical thinking skills, you're going to need interpersonal skills, just like all other jobs. You're also going to need, obviously, some scientific smarts. You're going to need some physical stamina. Hydrologists, particularly young hydrologists, sorry, but Marinella, you made it sound like I'm a little old. You said I've been around for a long time and a strong supporter of this forever. Well, I'm in my early 50s, and I love to get out there, but I can't walk 10 miles in the clay anymore like some of my students can. Not that far, really. But you have to have the willingness and the ability to get out there and collect data as a scientist. Now, it doesn't necessarily mean that you have to be a scientist. The job outlook for a hydrologist is very good. It's slightly above average compared to other jobs, particularly in areas like ours in deep South Texas, whereas Dr. Cheng talked about the recurring droughts and the scarcity of water means that we're going to have to be investing a lot, and we need trained scientists, engineers, geologists, geoscientists, a whole bunch of other areas that deal with water directly or indirectly. Just give you an idea from the Occupational Outlook Handbook from the Bureau of Labor Statistics, similar occupations to hydrology. I'm just going to go through this list real quickly. Obviously, civil engineering, like Dr. Cheng and I as our background, atmospheric scientists, including meteorologists, agricultural engineers, conservation scientists and foresters, environmental engineers, environmental science, environmental scientists and specialists, obviously hydrologic technicians, geologic technicians, geoscientists, and even mining and geological engineers are important areas that work directly with water. But aside from all of that, indirectly and or through the policy side, there are a whole host of folks that we need on the policy side, on the legal side, and on the business side to know about water. And I strongly encourage students, if they want to do this type of work, they do not have to be an engineer. You do not have to be a scientist. You can be a lawyer. You can be a business expert. You can be a policy expert. You can even be a criminal justice major and work with the area of water. It is usually easier to get your technical degree first, maybe a bachelor's in a science degree in a physical science, and then go on and get your law degree or your MBA or something like that. And you are going to be quite employable. You're going to be respected. And in some circles, you're going to be feared because you have a broad background across a wide array of knowledge. So I strongly encourage my students, if sometimes we have folks that want to be scientists, they don't cut it. Yeah, fear is good. They don't necessarily always cut it, and that's okay. I tell students, hey, that's all right. Yeah, and some of the most influential ex-students of mine that are out there right now with the Water Development Board, with TCEQ, with the EPA, with Parks and Wildlife, went another way after a couple of years, but they have come back, and it's like exactly like Ana Barrera just said, it is extremely intersectional and highly interdisciplinary. And so we need people from all different backgrounds. Now, of course, I'm the School of Earth, Environmental, Marine Scientists and Sciences and an engineer. So I'm going to hopefully try to recruit you to those purposes, because we need students in this college and we need engineers and scientists, but we need everybody. Like we say, we all live in a watershed. We all need water to survive, and the environment and our relationship with water is critical for our sustainability. So it's a great way to start off this week. I thank you for the invitation and the opportunity to once again talk to some of the students throughout this great area we live, work, and play in.
Thank you so much, Dr. Benavidez. And with that, we're going to start wrapping up, because we are already at that time where we were supposed to be at an end. So just bear with me. Dr. Benavidez, we will share your contact information in case there's any questions, so that you can answer those questions. I apologize. We are already stressed for time. So thank you again for your participation. I want to thank everyone for joining us. Tomorrow we will continue with Sustainable Development Goal number 15, which is life on land. It will be a different link, so please pay attention. It's at the same time, just a different link. We have a wonderful program set up for you, just like today, with several presentations, several videos from some of our subject matter experts with reference to life on land. So we hope you will join us. In the evening from 6 to 8 tomorrow, we will have our first of the Film Fest features, which is The Year the Earth Changed. It's an amazing documentary. It speaks about the changes during COVID and what happened to the planet during that time. Very interesting to see things that have never been seen before. So please, if you have the opportunity, go get some popcorn tonight so that tomorrow you're ready and you can watch this documentary, which is an incredible documentary. We do have a film fest for this week starting tomorrow. So these are the films that will be featured. If you haven't seen them, please go to our Sustainability Adelante film series and you will find the dates and the links to each and every one of these. They are different links. We had to get different links for each individual activity we're having during Earth Fest. So I hope that you get a chance. We also have a podcast series. I mentioned it to you earlier. I'm going to ask Jeremy to please share that link with you. We have anywhere from 15 to 20 different podcasts all related to sustainability. Among them, some are environmental. So if you really want to focus on those, please check those podcasts out and please visit the Sustainability Adelante podcast series. Again, I want to thank everyone for their continued dedication, commitment, and support towards education for sustainable development. I want to thank all the attendees, presenters, and community partners. This was brought to you by the School of Earth, Environmental, and Marine Sciences, along with the Office for Sustainability, in partnership with the Division of Finance and Planning, the Division of Research, the Office of Engaged Scholarship, Community Engagement, Upward Bound, and Gear Up. I also want to thank all our staff here at the Office for Sustainability, the office assistants, the grad assistants, and the interns. Believe it or not, there's a lot of work that goes on behind the scenes to put these type of events together, from the graphics and the video production and the podcast team. All our interns are always working really hard to put all of this together as well. So I want to thank all of them. And I want to thank Jeremy for helping us also with today's technology. So again, thank you. We will continue tomorrow at this time at 9 a.m. and we will see you then. So have a wonderful day and can't wait to see you. If there's any questions or concerns, please don't hesitate to contact our office and we will try to fix whatever didn't work out today to make sure that it's more smooth and works fine tomorrow. Thank you so much, and we'll see you again tomorrow.